So how's all 0 of you doing? Good? Good? That's great. Awesome. Okay, so we don't do offline padding because that's really expensive and that's actually really annoying to deal with. This paradigm that I'm taking from here that you see right here, this is taken exactly from automatic speech recognition, ASR systems. The goal is that with ASR systems, you were just simply framing the audio and making predictions as to which phoneme is in each frame, right? The ASR paradigm really informs what I'm doing here because the whole paradigm that I'm trying to build out here and the underlying hypothesis that automatic speech recognition system or automatic speech recognition type training is sufficient for detecting deepfakes. This is the underlying hypothesis that I'm building out to test and see if this works. So, okay, so we have, let's go back to our classic audio file. And, you know, maybe we convert it to a Mel spectrogram. So you can see this is kind of what a Mel spectrogram looks like. I can't drag it in here. That sucks. So you have something like this. And the idea is that, so this is over time every 5 seconds, right? So let's say this was milliseconds, all right? This way I could just kind of get my point across here. Let's say this was every 5 milliseconds. Well, phonemes, let's look up the average duration of phoneme. I'll take this. It's about 50 milliseconds, okay? So if the average duration of a phoneme, which is b, k, right? Like the core sounds that make up the language we speak, it's very likely, obviously this is 40 seconds, but let's say it's 40 milliseconds. This frame that we're seeing probably makes up one phoneme. And the goal of ASR, let's say this is 2 seconds. The goal is to take each frame of, let's say 50 milliseconds, all the way to the last 50 milliseconds, and then run a classification system in which we'll have 30 labels, right? So we'll have, let's say, 26 letters, a blank, maybe punctuation, period, comma, exclamation. I don't know what else. I know that in ASR training, it won't just be the set of letters. I know it'll be the set of letters, blank, and then other additional things. So let's just say it's punctuation. And then what we're doing is on a frame-by-frame basis, we're saying, I think we're trying to get the network to learn, I think this 50 millisecond frame is, this label, let's say label 7, which then maps to, F or whatever. And then this still may be 7 because maybe our prediction frame is smaller than the entire phoneme. So maybe this might still be F, and then this frame is U, and then this frame is still U, and then we keep going until we have C, K, K, and then Y, and then all of a sudden we have suddenly trained a network to say fuck you. And lo and behold, we have an ASR system. So at its core, what we're doing is training a network to make a prediction on each frame, and each frame will be then classified to a phoneme. Now, the reason why I outline this is because this core idea is what I'm trying to build out for deepfake detection. Now, instead of having, let's say, a classification set of 30, I want to reduce it down to 2, real and fake. And so now, let's say we're using a convolutional-based system. The features that are being learned to discern between the features of each phoneme, we no longer need that compute and the direction of learning, so to speak, to go in the direction of being able to discern between phonemes. What we want is those convolutions, maybe if there's an RNN, maybe if we're using attention, maybe if it's like whisper, for example, we want that learning mechanism to shift away from discerning between phonemes to discerning between the characteristics of, generally speaking, any phoneme. If we have F here and we have another F here, but for some reason a bad actor stitched together and this is a fake F, we should be able to discern between the real and the fake F, the real and the fake A, the real and fake any letter, any word, any sound, ideally. So this is why I'm heavily pulling from ASR when it comes to this pattern transform collate function, and this is why we're doing the dynamic padding. We shouldn't care about what the length of the audio file is that we want to run prediction on. Same with ASR. We'll just pad it dynamically to the longest in the batch. And, we'll run the necessary transforms. That's no problem. And then we'll have the batch, and then we can train. And I think this is sufficient to work. As you can see, I do have checkpoints here. I did an end-to-end ASR style with a cross-entropy loss. This was Deep Speech 2. I pulled this from Assembly AI. Why is my thing over here? Assembly AI train ASR. They have, yes, I believe it was this one in which they kind of give, no, this wasn't it. No, this wasn't it either. They have one where we build they build Deep Speech 2. And so I use this is the checkpoint here, and you'll even see the models. Where's audio, not data, audio sleuth, trainer. Oh, detection mod. Oh, yeah. So these are, I already have the reference here. I made marginal naming changes in documentation. This was just for my own. That way I made sure I understood the code that I was implementing. But at its core, I already tested out Deep Speech 2 in a very haphazard way, not really fitting within this package. And it did show promise. And so now really what I'm trying to do is just make the whole thing work as a comprehensive Python package, and then maybe build an even more complicated system with more data, maybe fancier optimization tricks for faster inference, maybe even seeing how much performance we can squeeze out of a smaller model. This is a convolutional based plus RNN style training. So by today's paradigm, this is quite small. We're not using multi-head attention and all this fancy stuff. So, maybe we can use Hugging Face just released Hugging Face Distill Whisper. The absolute brilliant researchers over at Hugging Face made a distill, like a student model version of Whisper, and they were able to get a similar word error rate, 51% fewer parameters, 5.8 times faster, while performing within 1% word error rate on out of distribution test data in a zero-shot transfer setting. So we have a arguably smaller version of Whisper that we could also train as well, compare it to Deep Speech 2. I think that wherever ASR goes, we can just kind of take these networks and plug it into this paradigm of training, and we could actually get something quite meaningful. Okay. So this is where we're at. This is what I think is, this is my hypothesis, and I'm building all of this. Discard. I'm building all of this just to even see. Whoa, what? I've never done this before in VS Code. What is this? Huh? Okay. But yes, I'm building all of this just to test this hypothesis, which could fail completely, and it could not be the case, right? But this is just how this shit goes. So, let's just go.